Hey guys, so today we're doing this video solving systems of quadratic equations. So we've done systems of linear equations. So if you recall, that's where we graphed lines. Remember, we graphed systems means more than one, so that would be two lines would be more than one, but it could be three, it could be four, it could be five, whatever. But typically we work with two linear equations before. And remember, we graphed them and then we saw where they met. And then we also use the substitution method. That's where we had them equal to each other and substituting into the other expression. And then there was elimination. Now, we can do graphing and substitution for quadratic equations, but elimination doesn't work. It would work if we only had quadratic equations, but now we're actually going to have systems where some are linear and well, one is linear and the other is quadratic. And I'll show you the examples of those next. But let's work with, I think, and I'm sure you're going to agree with me really soon, that substitution is a better method than graphing. And I'll show you each example in a moment. So let's recall all the steps for substitution that we once knew, and then we'll solve a problem after this. So step one. Step one says solve one of the equations for one of its variables. Step 2. Substitute the expression from step 1 into the other equation and solve for the other variable. Step 2. Substitute the value from step 2 into one of the original equations and solve. And remember, your answer was always a point, the point that those two lines met at. So it's an x and a y. So now let's actually work with an example solving the system. Here's our system. Y equals x plus 4 and y equals 2x squared plus x minus 4. So if you look at this equation, what kind of equation is this? Linear, you got it. And what kind of equation is this? Quadratic, you got it. So we're having a line and a parabola. Where do the line and the parabola meet? So try to picture that. Where's that going to meet? So if you're like just picturing, that's our coordinate plane, right? X and Y. You're picturing a line and you're picturing a parabola. So how many places do they meet? Well, typically two. But it's totally possible that they never meet, right? Say here's our parabola, and our line is horizontal. So that would be a no solution case, but we're not dealing with that too much today. And then what else could happen? Maybe here's our line, and maybe the parabola meets it at one place. Right, that's also totally possible. But let's talk about the basics of how we're going to solve these, not our possibilities. Okay, so start looking here. Here are two equations. We have y equals x plus 4, and our second equation, y equals 2x squared plus x minus 4. So step 1, solve both equations for y. Well, step 1 is done. Check. Y equals. When it says solve for y, that means get y alone. So that's done. Step 2, we like it when steps are already done. Step 2, substitute x plus 4 for y in equation 2 and solve for x. So here's equation 2, here's my y. So I'm substituting x plus 4 in for y. So I have x plus 4 equals 2x squared plus x minus 4. And now I'm solving for x. So I subtract x from both sides, and I subtract 4 from both sides, so I have 0 equals. And then I have 2x squared, nothing to change. X minus x is gone. Negative 4 minus 4 more is negative 8. So now I'm here. And now to eliminate, to factor this out, right, I have a greatest common factor of 2, so I can divide out my 2 because it's an equation. 0 divided by 2 is 0. 2x squared divided by 2 is x squared. And negative 8 divided by 2 is negative 4. So now I'm here. And I have 0 equals x squared minus 4. Well, this is the difference of two squares. So if I made my magic x, right, magic x, what multiplies to negative 4 but adds to 0, well, that's positive 2 and negative 2. So that's why I have here x plus 2 times x plus 1. I factored this out. Whatever method you chose to factor it out is totally fine. And then I solve for it. I have x plus 2 equals 0 and x minus 2 equals 0, meaning x equals negative 2 and x equals positive 2. So that is all in step 2. Now we look over here at step 3. Step 3, if you remember, says substitute negative 2 and 2 for x in equation 1 and solve for y. So I have two answers. So I plug in negative 2 for, and let's pick either equation, but let's obviously pick the linear one. So negative 2 in for x in my equation y equals x plus 4. Y equals negative 2 plus 4 is y equals 2. So this is not my answer. My answer then is negative 2, positive 2. Other point that these line and parabola meet at is here. So I plug in 2 for x, and 2 plus 4 is 6, so 2, 6. So my two solutions are negative 2, 2, and positive 2, 6. So if you're picturing the quadratic the parabola and the line where they would meet, here's the first point that they meet at, negative 2, 2, and positive 2 right there. Right? So wherever these lines are and this parabola, this line is, and the parabola is, these are the two places that they both are at. Okay, one more of these boards, guys. So example 2. Oh, there's graphing. Yay! So it says solve the system by graphing. So I have my equation y equals x minus 1, and I have my equation y equals negative x squared plus 4x plus 3. So let's first deal with our linear equation. I got to think, what's my slope, what's my y-intercept? If you remember how to graph this, my slope, oh, that's 1 because it's the coefficient of x, and that's 1. So rise 1, run 1, rise 1, 1, run. And my y-intercept is negative 1, so that's my starting point. So I plot my starting point at negative 1 on my coordinate plane, and then I rise 1, run 1. Plot a point, rise 1, run 1, plot a point, and keep going until I draw a nice line, use a ruler, make it look real good. Cool. Now we just learned how to graph quadratics in this section, right? So that's what we're working with now. The first thing to do, my second equation, is a quadratic function. So I find my axis of symmetry, my x value for my vertex. So I plug in the opposite of b over 2a, so that's negative 4 over 2 times negative 1, which is negative 4 divided by negative 2, and that's 2. So my axis of symmetry, which I didn't draw in here because I didn't want any extra stuff, is x equals 2. So that's that vertical line that goes through when x is 2. So now I have to find my actual vertex. I know it's on this vertical line x equals 2, but I plug in 2 for x. So positive 2. Y equals then negative parentheses 2 squared plus 4 times 2 plus 3, plugging it into my equation here. And let me move this up so you can see it a little better. There we go. So then I do negative 2 squared is really like 2 squared, which is 4 times a negative, and that's negative 4. 4 times 2 is 8, and plus 3 is plus 3. Negative 4 plus 8 is 4. 4 plus 3 is 7. So that means if when x is 2, y is 7, that's my vertex. So I look here, 2, 7, there it is. I also know my y-intercept is 3, so I plotted that point. I also know that the axis of symmetry is x equals 2. So I have another point over here at 4, 3. So 0, 3, and 4, 3 are 2 points. And then I just looked at, okay, positive 1 and positive 3 are the other points that are around my axis of symmetry. So I plugged in 1 for x. 1 squared is 1 times negative 1 is negative 1. 4 times 1 is 4. Negative 1 plus 4 is 3. 3 plus 3 is 6. So I have the point 1, 6. And if I plugged in 3, it would also be 6. So I drew my u. Then it looked like I met here at 4, 3, and here at negative 1, negative 2. Now, especially 4, 3 seemed like a done deal, but this negative 1, negative 2, I wasn't certain because I drew it kind of squiggly. So I had to check to be sure. So I plugged it into both equations. So I plugged in 4, 3 into y equals x minus 1, and I got a true statement. 3 equals 4 minus 1? Yup, it does. Now this took a little bit more work, but I also plugged in when x was 4, I plugged in 3 for y and x equaling 4, and I did get a true statement. So I knew 4, 3 for sure was a solution. This one was my uncertain one, so I had to plug it in to be sure. So I plugged in -1 for x and -2 for y. And -2 equals -1 minus 1? Yep, it does. So there we go. That's a solution for that one, but it doesn't mean it's for the other ones. You have to check both. Then I plugged it in, and remember, funny bunny business here with all these negatives. You -1 squared times -1 is -1. 4 times -1 is -4 plus 3. And does that equal -2? That's the question. And -1 minus 4 is -5. -5 plus 3 is -2. Yes, it does. So that means both -1, -2, and 4, 3 satisfy both equations. Lots of work here. So the solutions are both of these. Now, could we have solved this another way? Could we have used substitution to solve this? You make that call. You do not have to solve by graphing. I absolutely will not make that mandatory. Solving by substitution only is a method, but there are some of you that preferred graphing when we did linear equations, so I'm going to assume that you still prefer. Okay, let's go have some fun.